Hello everyone and welcome back. Now in this second video of the chapter Corneal Anatomy, Physiology and Wound Healing of ENOF, I'll be talking about the stroma and the endothelium. Now in this diagram, this is the epithelium which we have already dealt with in my previous video. This, the major portion, the thick part, this is the stroma. The stroma forms the major central thick part of the cornea, right? Now, if you have seen my previous video, you will be able to identify what this picture is. But if you haven't seen, just go back and see it again, or just go back and see it. And what you can appreciate in this picture is this word-like pattern, like as if something is coming from the periphery and is being deposited from the periphery and it is moving towards the center, this centripetal movement. Now, this is deposition of a substance in Fabry's disease. This is vortex keratopathy or cornea verticillata, right? Now, this is in association with the X, Y, and the Z hypothesis, right? Now, let's talk about something about the stroma. Now, what happens in the 7th week of gestation? There is a second wave of neural crest cells. See, there are total 3 waves of neural crest cells, right? So the second wave of neural crest cells, it forms the early corneal stroma. This corneal stroma, it provides important structural integrity and it comprises roughly 85% of the corneal thickness, right? Now this stroma, it differs from other collagenous structures. And how it differs? It is transparent, number one, and it has got a different biomechanical properties. Now these functional properties, it results from the precise organization of stromal fibers and the extracellular matrix. Now what is this precise organization? These fibers, they are arranged in a parallel fashion within each lamella, right? Now they are arranged in a parallel fashion within each lamella and they are arranged at angles relative to fibers in adjacent lamellae, which reduces the scattering of light, right? And one more important thing is the acellular condensate of this anterior part of the stroma. It forms the Bowman's membrane, above which the basement membrane of the epithelium rests, right? Now this is the diagram. As we can see that these lamellas are arranged in a parallel fashion and at angles to the adjacent lamella. Right, this lamella is at angle to the below one and this lamella is at a certain angle with the below one. Right. Now see what happens is that the stromal collagen fibers, they are mostly made up of the type 1 collagen, but in addition to the type 1 collagen, they forms a heterodimeric complex with the type 5 collagen, and this results in their unique and the narrow diameter. In addition to the type 1 and type collagen, they are surrounded by specialized proteoglycans, which are keratin sulfate or chondroitin sulfate or dermatin sulfate side chains, and the major cell type are the keratocytes. Right, all these things, they maintain the extracellular matrix environment. Okay, now these are the keratocytes, these are the cells, and these cells, they secrete or they deposit the keratin sulfate, the chondroitin sulfate, and all the other things. Now there are some soluble proteins also. These are the crystallins. They represent about 25 to 30% of the soluble proteins in the keratocytes, and what they does is they reduce the backscatter of light. Right, they reduce the backscatter of light and they also maintain the corneal transparency, which is very important thing, because if the cornea is not transparent, we will not be able to see anything. Right, the corneal nerves and the sensations, they are derived from the nasociliary branch of the first ophthalmic division, that is the V1. The first ophthalmic division of the trigeminal nerve, it supplies the cornea. This is an important MCQ question, so all the students should remember it, that this is the nasociliary branch of the ophthalmic division of the trigeminal nerve, right? Okay, so a whole lot of time we talk about the DM folds. We say that this patient has got descemet membrane folds. Now, why does there are only folds on the posterior stroma? Right? That why does the posterior stroma tend to develop folds more easily? So the answer is that there is an organizational difference in the collagen bundles of the anterior stroma, and this contribute to a tighter cohesive strength in this area. The anterior area is tight, it is more rigid, right, as compared to the posterior one. So this explains that why the anterior curvature resists change through stromal hydration much more than the posterior stroma. So we often talk about the posterior DM folds. Now we talk about the endothelium. So what happens in early embryogenesis? This posterior cornea, see, if this is the cornea, this is the anterior one, this is the posterior part. Okay, this is the anterior. Now this posterior cornea, it is lined by a neural crest cell derived, the neural crest derived monolayer of cuboidal cells, right? Now immediately anterior to the endothelium is a discontinuous homogeneous cell layer, which is the Descemet's membrane, right? So what I have said till now, that in early embryogenesis, this posterior cornea is lined by a neural crest derived monolayer of cuboidal cells, which will be forming the endothelium, right? There are some cuboidal cells, this is a monocellular layer, so this will form the endothelium. Now immediately anterior to the endothelium is a discontinuous, a homogeneous and acellular layer, which is the Descemet's membrane, right? Now this Descemet's membrane, it fuses peripherally with the trabecular beams. Okay. Now this fusion site, which is known as the Schall-Base line, this is a gonioscopic landmark that defines the end of the Descemet's membrane. Right? Now the intact human endothelium is a monolayer, and this monolayer, it appears as a honeycomb-like mosaic when viewed from the posterior side. Now this, you can see, this is a honeycomb-like mosaic. The cells are like this. Okay, I'm not good at drawing, so yeah, they are like this, and they are like well opposed to each other. Okay, so these are the honeycomb like mosaic. This is a monolayer, so it forms the endothelium. Now this endothelium, it maintains the cornea in a deturgescent stage or in a dehydrated state. There is a total of 78% of water content in the cornea. So our cornea is always in a relatively dehydrated stage, right? Because there's just 78% of water in the cornea. So what happens is there's a high density of sodium potassium ATPase pump sites on the lateral margins of the endothelial cells. Now this endothelium, it continuously secretes the Descemet's membrane throughout the life. It starts from in utero and it ends till the death, right? Or it continues up till the death. So this anterior portion of the Descemet's membrane, which is formed in utero, it has a distinctive banded appearance. But the Descemet's membrane, which is produced after birth, that is unbanded and has an amorphous ultrastructural texture, right? Okay, the central endothelial cell density, it decreases at a rate of 0.3% per year in normal cornea. The rate of decrease is 0.3%. This is also an MCQ question. Now, what is polymegathism and what is pleomorphism? Increase in cell size, that is mega. Variation in cell shape, that is morpho, right? Morphology is how it looks, what the shape it is. So variation is pleomorphology, that is pleomorphism. Increase in size, that is polymegathism. Now if the endothelial cell count in a cornea is less than 500 cells per millimeter square, this type of cornea is at risk for the development of corneal edema. Okay. Now if there is a corneal edema, now this is a normal cornea. Now if it is filled with water because of edema, it will be thick. So Measurement of the corneal thickness, which is called as pachymetry, which is again an MCQ question. It indirectly reflects the endothelial function. Increase in thickness of the cornea, it reflects the failing endothelium. Okay. The average central corneal thickness is about 0.5 and the peripheral is about 0.7. Okay. Central is 0.5, peripheral is 0.7. This is also an important MCQ question. Okay, so I will end up this video now. In my next video, I'll be talking about the corneal wound healing. And yeah, since it is corona times, you might not be attending classes, you might not like to study, but just remember one thing. If you can't fly, then run. If you can't run, then walk. And if you can't walk, then crawl. But whatever you do, you just have to keep moving. Okay? Bye bye.